Okay, hey guys. This is lesson 2 of financial modeling, which will be all about arithmetic series. So in the last lesson, we looked at arithmetic sequences, which is a pattern of numbers where we're adding on a constant term each time. Okay, the difference between a sequence and a series is that a series is when you're going to add those terms together. So a sequence is just separated by commas, like 1, 2, 3, 4. A sum or a series, they mean the same thing, is 1 plus 2 plus 3 plus 4. Okay, so when you do a sum or a series, you're going to get an answer at the end. And the series at some n value is going to be the total up to that term. Okay, so in our notes here, the sum, and we're going to be using this sigma notation occasionally, all right? It just means the sum, so adding them all up, of terms in a sequence. That's what we call a series, all right? Again, what makes it arithmetic is that we're adding on the same thing each time. So what I asked you to do at the end of last lesson was to consider and find the sum of the numbers from 1 to 100. So that's saying, add up 1, 2, 3, all the way up to 100, what are you going to get as your answer? Okay, now, obviously, I'm about to show you a way to do that using arithmetic series. Particularly, we know it's arithmetic because you're adding 1 each time, all the way up to 100. We're going to start by considering it in kind of a problem-solving way, and then I'll show you how we can get that back into the formula that we're going to derive. Okay, so what I first want you to think about is breaking 1 to 100 into pairs and going from the top and the bottom and having that as our pair. So the first and last term is going to be what's really important with these series. Okay, so the first and last term is going to be 1 plus 100. All right, so we get 101. If we then go in from each direction, so one more up and one more down, we're going to get 2 plus 99, which is again 101. If you go in again, you're going to get 3 and 98, 101, 101, blah, 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 blah. Hopefully you get the pattern that all the pairs from 1 to 100, if you're going to meet in the middle, are going to add to 101. Okay? Then all we need to consider is, well, how many pairs would there be? Because if each pair adds to 101, if we know how many pairs there are, we can just multiply 101 by how many there are, and that should be our answer. Way easier than adding it all up. So the number of pairs, you got to think about, well, it's going to be the number of terms that we're looking at from 1 to 100, and it's going to be half of that because I've paired them all up into groups of 2. So I'm just going to grab 100 divided by 2, which means I'm going to have 50 pairs. Okay, so if I have 50 pairs, that means I've got 50 lots of 101. Okay, and that will be my answer. So, oh goodness, the maths should be what, 5,050, I hope. I'm genuinely going to check that because I've been out of maths mode for far too long. So you got 50 times 101. Don't worry, I'm a genius. It's all good. And that's it. That's one way that we can use arithmetic series to answer a really common problem. So for any arithmetic sequence starting with, and it really should say arithmetic series there, I guess, but that's my bad. With starting value A, which is what we use when we talked about sequences as well. And we're going to come up with a letter, a variable, for the last term. All right, the last term, it's going to make sense to just call that L. That's my lowercase l. You can do an uppercase if you need to, but as I'm going to show you in a second, in the reference sheet, it looks like that. So kind of like a fancy L with a serif. That's what we call the little flicks. So from what we just did, to find the sum for any number, it's going to be the first and last term added together, because that was like our 1 and our 100. And then we figured out, well, how many of those are we going to have? That's going to be the number of terms divided into 2's. And that's our formula for series. Okay, so it's the first and last, and it's going to be half of the number of terms. So if I was to jump to this reference sheet real quick, you can see that under the heading sequences and series, we have to find any term. That's what we did this week. I don't know when I posted this lesson, but that was in our last lesson, arithmetic sequences. Now that we're looking at series, it says an S instead of a T, because you're finding the total at that point instead of the term. Okay, the sum, if you will. We have that formula just here. You got the number of the term over 2 and the first and the last term added together. Now, it's a big scary formula just there as well, and I'm going to quickly show you what that is. So that's alternatively, if you don't have the last term, then we can use, I've written it here so I don't want to lose it. We can use that bigger formula. It's going to get the same answer. It's still SN, but it's just not using that last term if we don't have it. Okay, so it's going to be n over 2. That's the same. We're going to go 2a plus n minus 1 times. Now d comes up. Remember, d from last lesson is the common difference. So like what we're adding on to each term. We can do that by doing t2 take t1. And that's the formula just there. So both work. Obviously, this last one's way nicer and easier. It's the one we just used to do the 1 to 100. If you have the first and last term, that's your go-to. If you don't have the first and last term, then you go to that big gross formula where it's in terms of the difference and the first term. All right, so let's do some applications using the arithmetic series formulas. The first one is about rows of stands, okay, set up to take school photos. And they are set up with an additional 2 places in each successive row. Okay, so as you go back, there's an extra 2 places, that kind of like triangle form that we tend to do. So if there are 10 students in the first row, now straight away that should be a clue when we're talking about firsts. That's going to be like our first term in our sequence. So that's going to be our A value. All right, so there's 10 students in the first row. How many students in total would there be in 5 rows? So that's not saying how many are in the 5th row. That would be the 5th term, T5. It's asking what is the sum at 5. Now to find that, we need a couple of things. We can go to our formulas. Do we know the first and the last term? No, because that would tell us like where it ends up. That would be T5 in that case. So if we knew how many people are in the 5th row, we could use that formula there. But we don't have that. What we do have is how many students are in the first row. And we actually do know the difference, the common difference, how many we're adding on to each row. It's given back here at the start of the question, okay? It says that we are setting up an additional 2 places in each row. So we're adding 2 spots on each time. That's actually our difference, 2. So we have A being 10, and we have D being 2, which means we can use the yucky formula to get an answer here, which would be this one in terms of A and D. So that formula is, and now I'm just going to jump straight to using it with 5 as our n, just because it saves us a line. We don't need to do it with n first. There's no point for writing the formula. So 5 over 2, it does help if you can actually write it. 5 over 2, and then we go 2 times A. Now that's just going to be 2 times 10, so 20. And I'm pretty sure it's n take 1. Yep. So, well, n take 1, that's just going to be 4 times our common difference, 2. Okay. And that's our formula. Yep, checks out. Cool. All we need to do now is type that into our calculator to get an answer. I do believe we should get 70. Again, it's always nice to give an answer here. Maybe 70 students in total, just to kind of like give ourselves an idea of what we just found. So that means in 5 rows, we've got 70 students all up. Okay, so now if there were 15 students in the first row, so what has that changed? It must have changed our A value, which is now 15 instead of 10. How many rows are required? Now, straight away, the question's framed differently because it's asking us to find what n is going to be, how many rows we need. So we're going to have to do some funky solving in a minute. So we're finding how many rows would we need to get 159 students. So that's going to be my sum after n rows. That's going to be my answer. Now, it didn't change my D, so I know that A is 15 now. D must still be 2, and I'm trying to get an answer of 159. So I'm just going to set it up. I can't use the final formula because I don't have the first and last term. So I'm again going to have to use this yucky one and pop in the actual value here. So I'm going to have 159 as my answer. It's going to be, now n is what I'm trying to find. So I can't actually write a value for n. Don't get stuck with that. Don't make it 5 or something from the last question. That's what we're trying to find. So n over 2, we've got 2 times a, which is going to be, I suppose I'll write it like this, just so that we're clear on what's happening. Now n minus 1 is just going to be n minus 1, and d is just going to be 2. Now we've got this set up, we've basically got an equation to solve. Okay, we are going to set this up. So the first thing I would do is simplify these brackets on the inside. So I might have to just come down through here. We've got 159. Now, I suppose we'll do it this way. N over 2 times 30